All right, so the idea is when you add two quantities, if you're living in one dimension, life is pretty easy. So for example, if you walk 4 miles, and then you walk 3 miles, how far are you from where you started? You're 7 miles. That's easy, right? It's simple addition. Likewise, if you walk 4 miles and then you walk this way 3 miles, how far are you from where you started?
1 mile.
1 mile. So when vectors, and when I say vector, you could think arrow, when quantities which have direction associated with them, so like taking a walk, or a force, or there's lots of other quantities that are vectors. When we're adding them together and you're living in one dimension, life is easy. You just add them or subtract them, okay? But what if I went for a walk and I went 4 miles and then I went 3 miles this way? How far would I be from where I started?
5 miles.
Well, because this is an easy triangle, you guys know it's 5, right? But in general, you can't take 4 and 3 and add them together in a trivial way to figure out the result, right? So when we are dealing with quantities which have direction, where direction matters, we call them vectors. And when we're adding those quantities, we've got to be a little bit more careful about how we add them than simply just adding numbers together. So, in this example here, I might call this vector A, and I might call this vector B. And so A would be 4 meters long, but because direction matters, I've got to tell you which way it's going. So far this year, we specify direction by either positive or negative. That's it. But now, since we're going to be working in more than one dimension, we've got to be a little more careful. So we're going to call the positive x-axis 0 degrees. So if an object is going to the right, it's at 0 degrees. That's the direction. But what if it's going up? What angle would that be? 90, right? And what if it was going this way? Be 180, right? So we're going to use the following convention for directions. When you think about the Cartesian coordinate system, here is x and here is y. We're going to call this 0 degrees. That, of course, would be 90 degrees. This would be 180 degrees. And if we went straight down, this would be 270 degrees. And you could also use negative angles. So, for example, negative 90 degrees would be positive 270, they're coterminal, right? So, when I specify A, I've got to specify the length of the vector, how far you go, and the direction. So this one is at 0 degrees because it's to the right. What about vector B, though? Which way is it? Actually, let me change this a little bit. I made it so that's hard. Let's do an easier one. Let's do vector A this way. Here's vector A, and that's 4 meters. Let's say vector B is this way, and that equals 3 meters. So what would be the direction of vector B? Josh?
90 degrees.
Yeah, it's at 90 degrees. And in the weird world of vector addition, when you add these two vectors together, you don't get 7, you get a result. So R is the result. So I'll draw that in red. The result is you end up over here, right? And that is 5 meters from where you started. And what would the angle of the result be? If you were right here,
45 degrees.
that's not 45 because it's not an isosceles triangle, right? If those are both the same size, it'd be 45 degrees. How would you find that angle in there? Somebody said it? Yes, Josh.
Is it 30 degrees?
Not 30 degrees. If it was 30 degrees, then this divided by that would be 1/2. This is 3 and that's 5. So, what do you think? How would you find it? 3? Yeah, you do.
Sure.
Do you know a trig function that involves an opposite side and an adjacent side? Tangent, yeah. So you might say that the tangent of this angle, whatever the heck it is 3/4. And if you knew the tangent was 3/4, how would you find the angle? Trevor?
Negative tangent or inverse tangent?
Third try, we lucky one.
Tangent.
We call the what? We call it the arc tangent. Arc tangent. But on your silly calculator, it's written like an inverse, right? So you can call it inverse tangent. That'll work. So what do you get? You do inverse tangent of 3/4.
36.87.
Yeah, 36.9 degrees. So in the weird world of adding vectors, 4 meters at 0 degrees plus 3 meters at 90 degrees is the same as, or is equal to, 5 meters at 36.9 degrees. Whether you go this way or you go that way, you end up at the same place. So you might hike here and then there, or maybe you just go directly there, 5 meters at 36.9 degrees. Either way, you end up at the same place, okay? So it doesn't matter whether these are distances. They might be forces. If somebody shoves on a box with 4 newtons of force this way, and somebody else shoves with 3 newtons of force this way, what is the net force? Well, what does net mean? It means add them up, right? So same thing. You'd have to add them up, but since they're not going the same direction, you'd have to think about vectors. So you would get a net force of 5 newtons heading at 36 degrees. The net force was as if somebody was pushing with 5 newtons this way. It's the exact same as if you pushed 4 newtons that way and 3 newtons that way. So we're going to see this all over the place in physics with vectors. So we're just going to learn a little nifty trick to add vectors. How do you get from here to there quickly? Okay? So to do that, I'm going to solve an example problem. And I'm going to give you copies of it. So you don't have to take any notes. You've got it here. Caleb, would you mind passing those out to everybody? So I'm going to solve the problem over on this other board. And I guess I better move my camera so Joey can, that'll give you a headache. So Joey and Dylan and everybody else can see what the heck we did. So here's the problem I'm going to solve. I'm going to add 2 vectors. I'm going to call vector A 15.0 meters at 75.0 degrees, and vector B is going to be 9.00 meters at negative 15 degrees. So those are my 2 vectors I want to add. So I'm just going to go through the process of adding these vectors. Okay? Hey, you're back. I guess Joey doesn't have to watch the video. We're making the video for, oh, there's Joey to the video. We're making a video for Dylan here since he's not here. All right, so we want to add these 2 vectors. So the first thing we're going to do is we're going to try to sketch a diagram, okay, of what's going on. So let's imagine we start right here. I'll use blue. I'm going to start right here. Now, if this direction is 0 and that direction is 95, which direction does A go? Go ahead, point. That's 0, that's 90, so it's going to be kind of like that, right? So the first vector is, do I have those numbers right, by the way? Read the top of the problem. Is it 15 at 75?
Yeah.
Okay. So the first vector goes something like this. And then the second vector goes, if this is 0, what's negative 15? Is it that way?
Down.
Yeah, it's down a little bit. Like that's negative 90, that's 0. So negative 15 is down a little bit like this, right? And if this is 15 long, this one's got to be a little shorter, right? Because it's not quite as long. Now, if you had a really sharp pencil and a really good ruler and a really good protractor, you could just solve this graphically. You could draw a line 15 inches long at 75 degrees. You could draw then a line 9 inches long at negative 15 degrees, and then you could just measure the distance from here to here and measure the angle. but we're going to assume we're going to do it analytically, not geometrically, okay? But you can certainly solve it geometrically. The way we're going to solve this problem is we're going to break it down into what we call components, okay? Now guys, I know, and I'll readily admit, you can solve this other ways. You can solve this with the law of sines. You can solve this with the law of cosines. You can solve this with analytical geometry. But the way I'm going to do it is the most straightforward. It's a little longer than some of the other ways, but it'll work every time. And most importantly, it's easy to turn this method into an algorithm so you can make a program to do it for you. And since we're going to do this all year long, by the end of next week, we're going to make a program on the computer to add vectors for us. Okay? So we're kind of feeding into what's coming next. All right, so what I'm going to do is I'm going to find the components of this. This is vector A right here. And this here is vector B. I'm going to try to figure out how far does A go horizontally, and then how far does A go vertically. And I'm going to call this leg A sub x, since it's the x component of leg A, of vector A. And I'm going to call this A sub y. Do my labels make sense now? Because it's the component or the part in that direction. I'm using x and y as the subscripts. Now, vector B. And by the way, this was 75 degrees in here, right? 75 degrees. Vector B. You also go over and you go down a little bit. So vector B looks something like this. To find its components, we're going to go this way and this way. And we're going to call this B sub x, and this is going to be B sub y. Now, if I were to find A sub x, how would I do that? What trig function would you use if you knew the angle and you knew the hypotenuse was 15? You'd use cosine, right? The cosine of 75 would be A sub x over A. And so, it's pretty easy to figure out that if you want to find A sub x, you take A times the cosine of the angle, which in this case is 15 meters times the cosine of 75 degrees. Okay? And you could do that. I don't really want you to spend a whole lot of time doing this because it's the same all the time. What we're going to do is we're going to make a table of our results, because that's what we're after. So I'm going to make a table. I'm going to find the x and the y component for vector A and for vector B. So, to find the component of vector A in the x direction, that's this here, we're going to do the same thing every time. We are going to take vector A times the cosine of the angle. So grab your calculator. Vector A is 15, so take 15 times the cosine of 75. What'd you get? 3.88? 3.89? Which one did I put in? 3.88. Okay, so I got 3.88. So do you guys see where that comes from? What about in the y direction? How do we find that? Well, we take A times the sine of the angle. So take 15 times the sine of 75. What'd you get there? Got it, Chloe? 14, give me a little more accuracy. 14.49. Okay? So what that's telling us is that when you go from here to here, you go 3.88 meters in the x direction. No, we're making a video for him though.
Okay.
So we go 3.88 in the x direction, and we go up 14.49. We found what we call the components of the vector, the parts of the vector going over and up. All right? Now, vector B, we do the exact same thing. To find the components of vector B, we take the length of B times the cosine of the angle. So take 9 times the cosine of negative 15, and it's already in the table there. You can just, what is it?
8.69.
8.69?
Yes.
And if you want to find the y component, you take b times the sine of negative 15. And what do you get when you do that? Anyone? Take 9 times the sine of negative 15. What'd you get, Chloe? Why is it negative? Anybody else get negative? Why is it negative, Caleb? Yeah, because it's going down. It makes sense. This tells you how far you go in the y direction. So the fact that it's negative means you go down. So what was the number? Negative what? 2.33. Okay? So you don't have to know that because your calculator will figure that out. Because the sine of an angle in the fourth quadrant, right? This angle's in the fourth quadrant, it's negative 15. The sine of an angle in the fourth quadrant is negative. So we go over 8.69 and we go down 2.33. Now, here's where the magic happens. Because the components, a sub x and b sub x, because they're going in the same direction, you can just add them. Because they're going in the same direction. So if you add these, what do you get? 12.57. So when I add these, I get 12.57. So I go over 3.88 over 8.69. So I end up over 12.57. And I go up 12.16 or 06. 16. So this right here is what we're after. These are the components of the result. You started here, you ended up here. How far did you go over? You went over 12.57 meters. How far did you go up from here to here? You went up 12.16. So what you end up with is a resulting vector. I started here. A went up like this, and then B went down like this. But the result is a vector which goes from here to here, and what we know are the components of it. We know how far this vector goes over. We call that the result in the x direction, and we know how far it goes up. That's the result in the y direction. And that's what these are. This is the result, how far you go horizontally. This is how far you go vertically. Okay? So, if you know those two numbers, can you find the length of this vector? How would you do it? Megan? Yeah, probably the easiest way is to use Pythagorean theorem, right? So, the length of vector r, we use that symbol to mean length or magnitude, the size of the vector, not worrying about the direction, right? Isn't that what absolute value is? It's how far you are from zero, not worrying about which way you are.
Yeah.
So those symbols in general in mathematics mean the size of a quantity. That's going to be the x component, this thing, squared, plus the y component, how far you went in this direction, squared, and then take the square root. That tells you how long the vector is. And so that was the last question on the warm-up. And some of you got it. Good job. I think that is 17? 17 and a half? 17.49 meters. And if you want to find the angle of the result, what direction is that result pointing? You could use tangent. The angle will be the arc tangent of the opposite side, which is the y component, over the adjacent side, which is the x component. And you plug those numbers in. All right, Grant, what's that angle going to be close to? This is about 12 and a half. That's about 12.
45 degrees.
It's going to be close to 45. Is it going to be a little bigger or a little less?
A little less.
Why?
Because,
Because you're looking at the answer and it's 44 is less than 45?
yeah, and then I was trying to figure it out, but I don't know.
This one's 12 and a half. This one's not quite 12.5, it's a little less. So the angle's a little less than 45. So an angle of 44 degrees is a 44.0, 44.05? Yeah, okay, degrees. So, here's what we can say. When you take vector A and you add it to vector B, the result is a vector which is 17.49 meters long and it lies at 44.05 degrees. That is the result. That's the answer. Okay? Now, it's a bit of a pain to go through this whole process, which is why by the end of next week, we're going to make ourselves a little computer program to do this work for us. But right now, to make sure we understand what we're doing, we're just going to do it the long way, okay? So when you get a problem, make a little sketch. You don't have to draw these little parts of the triangle if you don't want. It's okay. But just try to make a sketch of what the two vectors are so you have an idea. Find the component table, and once you find the component table, these two numbers will tell you the answer. These two numbers here will tell you how to find the length of the vector and how to find the direction of the vector. Okay, does that make sense? So we're going to practice this on a couple. The first problem, you're going to all do homework 4.2. The first problem, everybody has the exact same problem. So if you get stuck or have trouble, your neighbor has the same problem, same numbers, they should have the exact same table you do. After the first one, you're on your own. Everybody gets different problems, different numbers. Okay? So go ahead and grab your computer, find homework 4.2. There's also a hint on number 1, but try not to use it, only if you get desperate. And take heart, we're not going to do this forever. We're going to build ourselves a computer program to do this for us.